Welcome to homework.
Body diagram of this scenario, we see that we have the box around here, and then it's on the floor. Now the box is moving horizontally. Let's say the box is moving from left to right, and then because of that, we have some forces that's acting on the box. First of all, we have the force that's acting on the box. Let's call that Fp. And since the box is moving from left to right, there will be some frictional force that's acting on the box, and the direction will be opposite because friction acts in the negative direction or in the opposite direction. Then in vertical direction, we have mg, which is acting downwards, and then we have the normal force, which is acting upwards. Let's say the box is moving with an acceleration a. So from left to right, the acceleration of the box is a. Now in first part, we need to figure out the coefficient of static friction. So for static friction, that means it should be equal to the normal. So we know that frictional force Fr, if that's a static friction, then this is going to be mu s times F. Let's call this force N, which is this guy over here. So let's actually call this guy Fn, so that we're just consistent with the units. Right. And by frictional force, it means that before the box starts to move, what is the frictional force that's acting on the block? That's the static friction. So this friction right here is just before the box starts to move. So that means um, in the horizontal direction, the box hasn't been started moving yet. So the total force in that direction is 0. So if we call this left to right direction as x, so the total force will be 0, and that's equal to Fp minus Fr, because Fr is f of Fr, which is this way, and Fp is from left to right, so they're balancing each other when there's a static friction, when we're calculating the coefficient of static friction. And from here, we see that Fp is equal to F of Fr, which is, from here we see it's mu s times Fn, where Fn can be found using the vertical motion where mg is acting downwards. And since there is no movement in the vertical direction, that means the normal force must counterbalance this force that's going in the uh, vertical direction. So that tells us that Fn is equal to mg. So we can use that relation over here. So that gives us mu s times mg. And from here, if we solve for mu s, that gives us Fp over mg. So Fp is 35 newtons, and m is 6 kg times 9.8 meter per second squared, which is g, and that gives us 0.6 as our coefficient of static friction. So that's part A or 1, whatever you want to call it. Now for part B, we have we have to find out the coefficient of kinetic friction, and this time the box is accelerating. And if we remember the diagram, we had the box moving from left to right, and the acceleration is given as 0.6 meter per second squared. So now again, if we use the given equations, we see the only thing that will change here is the horizontal direction, because now the box is moving. So the total force will be m times a, because the box is moving with an acceleration a, so total force should be mass times a. On the other hand, we know that there is Fp, which is acting from left to right, and then there is F of Fs, which is acting from right to left. So let's call it R for the kinetic friction. So yeah, I think it's Fr. So yeah, we have Fr, which is going from right to left. So we'll have Fp minus F of Fr, which is equal to Ma. And the reason we are subtracting F of Fr from Fp is because the whole system is moving from left to right. That means this force is dominant over this force. Now, if we solve for it, again, we can use, for this case now, it's the kinetic friction. So this is going to be mu k instead of mu s times F of n. And if we remember this correctly, we have mg acting downwards, and then we have Fn, which is acting upwards. So from here, we see that F of p minus mu k times mg is equal to ma. And from there, we see that mu k is equal to F of p minus ma divided by mg. Now the given values are, for Fp it's 35 newtons, m, or the mass of the block, is 6 kg, a, or the acceleration, is 0.6 meter per second squared, and g is 9.8 meter per second squared. And from here, if we plug in all the numbers over here, we see that mu k is 0.53. Thank you.